So for number 3, we are required to find the equation of the normal to the curve y is equal to 8x over 4 plus x squared at x equals to 2. Now, the first step will be to find the gradient function, then we find the gradient of the tangent at x equals to 2, and then we find the gradient of the normal, and then the equation of the normal. So this will be my u, and that will be my v. So dy over dx will be equal to 4 plus x squared multiplied by the derivative of 8x minus 8x multiplied by the derivative of 4 plus x squared, all this over 4 plus x squared squared. This will be equal to 4 plus x squared multiplied by 8 minus 8x multiplied by derivative of 4 plus 4 plus x squared, but of course derivative of 4 is 0x squared, that will be 2x. All this over 4 plus x squared squared. Right, so and then we can just simplify the numerator. So that will be 32 plus 8x squared minus 16x squared over 4 plus x squared squared, which will be equal to 32 minus 8x squared over 4 plus x squared squared. And that will be the gradient function. So at x equals to 2, the gradient of the tangent will be equal to, you substitute 2 in place of x, so that will be 32 minus 8 multiplied by 4, which is 32, over 4 plus 4 squared. Now, obviously, you can notice here that 32 minus 8 multiplied by 4 is 32. So this will be equal to 0. Yeah. So the gradient of the tangent will be equal to 0. What this implies, what this means is that we have a horizontal tangent at x equals to 2. So this implies that we have a horizontal tangent at x is equals to 2. So if we have a horizontal tangent at x is equals to 2, then that will mean that the normal will be a vertical line at x equals to 2. But we know that on a Cartesian plane, a vertical line will basically be the line in the form of x equals to something. But because this is happening at x equals to 2, that means that the equation of the normal will be x equals to 2. So this means that the equation of the normal is a vertical line. So this means that the equation of the normal is a vertical line at x is equals to 2. So basically that is the equation of the normal. Yeah. So this is the equation of the normal, because it's a vertical line which is parallel to a horizontal line, and it occurs at x is equals to 2. Okay, number 4. Um, we have this function, and we are required to find the derivative of this function. Now I'm going to rewrite it, and I plan to use quotient rule to be able to find the derivative of this function. So first of all, we have f of x will be equal to, now this is same as 1 minus 1 over 2 plus x to power, if you use your knowledge on index notation or indices, this is same as 2 over 3. So this will be 2/3. The power is 2/3. Um, Now what I'm going to do is to rewrite what is inside this function as such that it ends up with a single denominator. So basically what I'll end up with here is 2 plus x, sorry, 2 plus x minus 1 over 2 plus x, all this to power 2 over 3. And then just simplify the resulting expression, which will be x plus 1 over x plus 2 to power 2 over 3. And this will be x plus 1 to power 2 over 3 over x plus 2 to power 2 over 3. Then basically I'll choose this to be my u and this to be my v. And then apply quotient rule. So if you apply quotient rule, f dash x of dy over dx will be equal to x plus 2 to power 2 over 3 multiplied by the derivative of x plus 1 to power 2 over 3 minus x plus 1 to power 2 over 3 multiplied by the derivative of x plus 2 to power 2 over 3, all this of x plus 2 to power 2 over 3. This has to be squared. Okay, moving on. Let's find those derivatives. So that will be x plus 2 to power 2 over 3 multiplied by apply chain rule. 2 over 3 comes in front, so you have x plus 1 to power negative a third, because 2/3 minus 1 is negative a third. If you differentiate inside, you just end up with 1, so that doesn't make any difference. Minus x plus 1 to power 2 over 3 multiplied by the derivative of the inside. Again, you bring 2/3 in front, so you end up with x plus 2. 2/3 minus 1 is just negative a third, and then multiplied by derivative of inside, which is just 1, so it doesn't make any difference, over x plus 2 to power 2/3 squared. So we can just write this as uh, x plus 2 to power 4 over 3. Moving on, we can simplify these numerators. So this will be 2 over 3 into x plus 2, 2 power 2 over 3, multiplied by x plus 1, 2 power negative a third, minus, again here we have 2 over 3 into x plus 1, 2 power 2 over 3, multiplied by um, x plus 2, 2 power negative a third, all this over x plus 2, um, 2 power 4 over 3. Now, of course, you can simplify this further, but I'll just stop there because what we need is just the derivative of this function. And that's basically what we have here.